Okay, let's see how we can implement this. So, suppose I have the same array. Okay, we'll say 7, 2, 1, 8, 6, 3, 5, and 4. Let's go ahead and write the indices underneath. Okay, and I will call this guy here, say the start, and I'll call the last index to be the end. So the first question was, how do we pick an index? I'm sorry, how do we pick a pivot? Okay, so there are many strategies of picking a pivot. Some are based on heuristics. In the notes, they show you, I think they pick the first element of the array. So in the online notes, they pick the first element here. I'm gonna go ahead and do it with the last element. Okay, the reason why we can pick is because we don't really know how the array is, how the data in the array is really positioned, right? I don't know where the best pivot would be, right? And you think, what would the best pivot be? Well, the best pivot will be hopefully to pick the element in the middle, right? So you don't want to pick the maximum element or the lowest element, because then you'll have to end up shifting everything to one side. Okay, so you're hoping that you pick a pivot that's right in the middle of the data. And how do you ensure that? Well, you can use some sort of heuristics by taking a few numbers and then, based on their position, maybe averaging them or picking an average index. Or you could try to infer from some information based on your data. So if you know your data is going to be ordered in a certain way, you can go ahead and pick a pivot based on that. But for right now, I'm just going to say I'm going to pick my pivot to be the last element. Okay, so my pivot in this case is going to be 4. All right, so I'll say int pivot is going to equal the left. Okay, so I'm going to leave a little bit of room here, because then we're going to move this into a plain function. Let's put it, I think, here. Let's go ahead and call this a function. So I'll say void, and I'm going to call this function called partition. And I'm calling it partition because I'm partitioning the array into two subchunks, right? I'm picking a pivot, and then I'm partitioning it into a left and right subchunks. So I'm going to call this partition. Let's go ahead and take in the array list. So we'll say array list int. We can go ahead and change this later to templates array, and then we'll, like we did before, like with merge sort, we'll say I have a start and I have an end. Perfect. All right, and then we said my pivot is let's go ahead and redo this. My pivot is going to be I think I'm going to pick orange here so we can distinguish it. My pivot is going to be the left. So it's going to be the last element of the range. All right, and then here's how I'm going to approach this problem. Okay, I'm going to say I'm going to have two indices, and please know that there are different ways of doing this. I think the notes show you a different strategy, and if you Google it online, you might find a different strategy. I'm going to show you a strategy that I've done in the past, and I know. I'm going to use two indices. I'm going to use an index I and an index j. All right, I is going to be the index that tells me all the numbers that are less than the index. So I will indicate the numbers that are less than the pivot. So right now when I start, I is going to be initialized to -1 because I will assume that all of the numbers are bigger than the pivot. That's what I'm going to assume when I start the algorithm. So I'm going to initialize I to be -1, and then I'm going to say, okay, everything that's at j and after is going to be bigger than the pivot. So at j or larger is going to be larger than the pivot. Okay, and as I move along each number through the array list, I'm going to be adjusting. Okay, so I'm going to be adjusting I and j. So as we're looking at, I'm going to say then, as we are going through each element in the array list, we are going to be adjusting I and j. Okay, and how we're going to be adjusting I and j, you'll see that as we're doing the, as we're going through the algorithm. Okay, so let's give this a shot, right? I will go ahead and say int I is going to equal, well, let's start with j, okay? Int j. Now you have to be careful. I can't say j equal to 0 like you learned with merge sort. I have to say j is equal to start. In our case, when I first start with the array, you know, the start will be 0. But I can't say 0. I cannot say 0 here because again, this is going to be called on sublists, right? So it's not always going to be 0. So you have to be careful about that. All right. And then int I is going to equal start minus 1. Okay. So in the scenario here where we have the start to be 0 and the end to be 7, okay, we see here that j is going to equal 0 and that I is going to equal -1, and then the pivot is going to equal 7. Okay, that's my first iteration through partition because I'm calling it on the whole array. Then when we start splitting it up, the start and the end will change, as you'll see later. Okay, so now we'll say here while, right? So now we're going to say while the j is less than the pivot, right? So j is at 0 right now, right there, and we're going to go all the way up to 6. So we're not going to include the pivot. And then what we're going to do next is we're going to compare every number to the pivot. So every number, so j points at that particular number. So we'll say if array of j is, in this case, we'll say larger than the pivot. Okay, I'm just going to move to the next element because, as I said, my assumption is that j points to the element to all the elements that are larger than the pivot. So if j is already larger than the pivot, you know, I don't have to do anything. Okay, so I'm just going to move j. So in our case here, j is going to move, and now j will become here. Okay, so now we say, hey, if what's at j is not less than the pivot, okay, so we'll say else. So in this case, we're saying, hey, the number at j is not larger than the pivot or is smaller than a pivot. I'm going to go ahead and increment I. Okay, And then I'm going to swap I and j. And then I'm going to increment j. And you'll see why this works. Okay, so let me clean the data here and we'll go through this example. Okay, so right now, if you guys notice, I is -1 and j is 1. So we're comparing in this case 2. I'm saying compare 2 with 4. 2 is less than 4. So let's go ahead and increment I. So in this case, I will move here. So now this is, oops, I'm sorry. This is I. Okay. And then I'm going to swap I with j. So I'm going to swap these two. And the reason why I'm doing that is because I know that j is pointing to an element that is less than the pivot, and I is pointing to all of the elements that are less than the pivot. So I have to put 2 at I in order for to maintain that rule that we made. Okay? So in this scenario here now, I will swap 2 and then with the 7. So then now we'll have the 7 here. Okay? And then I'm going to increment j to the next element. Okay? So now we keep doing this. I is still pointing to all of the elements that are less than the pivot. All right? Everything after I up to j is bigger than the pivot. So that's our rules that we're trying to maintain as we go through the array list. All right, so j is less than the pivot, right? There's j right there. 1 is less than 4. So we're going to go ahead and swap, increment I, I'm sorry. So we're going to increment I. So now I will be here. Okay, and we'll swap 1 and 7. 1, and then we'll put 7 here. Again, I'm preserving everything in my array list. If you guys notice, when I move j over, and I realize that j is going to be smaller than the pivot, okay, the next thing after I is always going to be bigger than the pivot. So I increment I, and then I swap the j with that I. Okay, it's kind of a interesting and interesting approach. Okay, so let's move on, and I'll show you this in as we go through another example. So now let's see, we increment j. We forgot to do that last time. Try to delete this. Okay, there we go. All right, so now we're going to go ahead and increment j. So now j is going to be here. 8 is larger than 4, so we're just going to increment j. So now j is going to be here. 6 is larger than 4. We're not going to do anything. And we're going to increment. Okay, great. Now j is at 3. Now here's what I was saying, okay? We found an element that's less than the pivot. So what we're going to do is we're going to increment I. And the reason why I'm incrementing I know that the element after I is always going to be bigger than I. So we're going to move I. So now I will be here. And now I'm just going to, I know that j is pointing to an element smaller than the pivot. Okay, there's 3. I know j is pointing to an element smaller than a pivot, and I is pointing to an element larger than the pivot, so I'm going to swap their places to preserve the order that I want to. So now we're going to have swap. So we're going to put the 3 here, and then we're going to put the 7 here. Okay, and then we're going to increment j. So now j will be here. Okay, now 5 is larger than 4, so we're not going to do anything, and then we're done. Okay, so the last step that I need to do, okay, is I have to put 4 in the right spot after I'm done with the partitioning, after we are done with the while loop. Okay. I'll give you a second, guys, and try to think where would I need to put 4 and how will I need to do that. Okay, so what did you guys guess? I know that 4 is going to be less than all of the elements of J. 4 is going to be less than, or let me put it this way, 4 is going to be larger than everything after I. I know that 4 is going to be larger than everything after I. So I have to put 4 one index after I. Right? So all I have to do at the end is I have to say swap, and then we'll say array, then we'll say pivot. Let's go ahead and make this orange because our pivot is orange. With I++, plus I, I'm sorry. Or let's not get fancy here for people that don't understand. We'll increment I, and then we'll put I there. I was going to do plus I, but I don't know if some people know what the difference is between I++ and plus I, so I'm not going to go there now. So we'll increment I, so now I becomes, we move I here, and then we swap the 4 and the 8. So now the 4 will become here, and then the 8 will go at the end. Oops, we'll go at the end here. So now I have 4 in the right spot. Okay, and then we are done with the partition. Okay, so now that we're done with the partition, excuse me. Now that we're done with the partition, I have to keep calling partition over and over and over again on each subhalf. So now I have to call partition on this side, and then I have to call partition on this side. Okay, so note that when I call partition on the left, so when I call the partition here, I have to start my start. Okay, my start is going to be 0, and my end is going to be 2, right? The indices 0 and 2. So how will I know that? Well, the function partition should return me where the pivot ended up being, because I have to know where the pivot ended up so I know what my left and right side are. If I don't know where the pivot ended, then I cannot call partition again. So you have to remember at the end, guys, to say, let's go ahead and erase this. You have to say return where the pivot ended up being, and the pivot ended up being in position I. All right, now we're done. We're going to go ahead and change the signature here. I'll say int. Okay, and now we're done. Now we can go ahead and implement QuickSort. And QuickSort now is going to be just calling partition the same way MergeSort was calling merge. Okay, I hope this made sense.